Welcome to the third session of our third module. So students, in the previous session we have already studied the concept of Prandtl-Meyer relation for a normal shock. So what was Prandtl-Meyer relation? Prandtl-Meyer relation was like V1 into V2 is equal to A star square. So V1 is the upstream velocity and V2 is the downstream velocity, or we can write reference Mach number in upstream. The product of reference Mach number in upstream and downstream will yield you unity 1. Okay, so based on this Prandtl-Meyer relation, we will do some more analysis of shock wave. So now we will try to determine Mach number downstream of a normal shock in terms of Mach number. So we will find a downstream Mach number as a function of upstream Mach number. Okay, as a function of upstream Mach number. So if you know the upstream Mach number, you can find the Mach number after the normal shock. So that is the idea of this particular topic. Okay. So students, we know V1, V2 is equal to A star square, right? A star square. Okay, A star can be written as, actually it can be written as 2A0 square by gamma plus 1, right? Gamma plus 1. Okay, now we know that v can be written as m into a, right? M into a is nothing but m into root of gamma rt, right? So v1 will be m into a1 or m into gamma rt1. Similarly, v2 can be written as m into sorry, this will be m1. Okay, m1 a1 and m2 root gamma rt2, right? So we can substitute this value for this particular expression for velocity in this particular equation. So you will get m1 root of gamma rt1 into m2 root of gamma rt2 is equal to 2a0 square by gamma plus 1, right? So instead of a0 you can write as gamma rt0, right? a0 is root of gamma rt0, right? So a0 square is gamma rt0 by gamma plus 1, okay. So you will get, so this root gamma r into root gamma r is gamma r, and this gamma r cancel. Okay, so what remains is m1 m2 root of t1 t2 is the remaining 2 t0 by gamma plus 1, right? Now you will get m1 m2 will be equal to 2 by gamma plus 1 t0 by root t1 t2. So actually students, t0 is equal to t01 is equal to t02. So stagnation value of stagnation temperature is same for both the sections. So it does not change. Okay, so because h0 is also constant, so h0 stagnation enthalpy is equal to h01 is equal to h02. So you can write t0 as t01 and t02. So instead of t0 you can write it as root t01 into root t02, right? Because t01 into t02, root of t01 into root of t02 will yield you t0 itself, right? So I am substituting that value, m1 m2 is equal to 2 by gamma plus 1 into root t01 by t1 into root t02 by t2. So students, t01 by t1 and t02 by t2. So you know the equation for stagnation enthalpy, you know the relation, that is root of 1 plus gamma minus 1 by 2 m1 square, right? So m1 plus m2 is equal to m1 plus m2 is equal to 2 by gamma plus 1 2 by gamma plus 1 into root of 1 plus gamma minus 1 by 2 m1 square, right? So that is t01 by t1, and t02 by t2 will be 1 plus gamma minus 1 by 2 m2 square. Okay, so this is the equation. Now in order to remove this root, you just do one thing, you just square both sides. So if you square both sides, m1 square into m2 square will be 4 plus 4 by gamma plus 1 square into that root goes. Root will be gone. Okay, 1 plus gamma minus 1 by 2 m1 square into 1 plus gamma minus 1 by 2 m2 square. Okay, now you just do one thing, you just simplify this equation, and you do one thing, you bring m2 square to one side, m2 square to one side, and if you do the rearrangement, I'm skipping all those rearrangement sections because those things can be done by yourself. Simple algebra, simple algebra. So I'm not writing all those steps. So if you rearrange this, you will get m2 square as 4 plus 2 gamma minus 1 into m1 square by 4 gamma m1 square minus 2 gamma minus 1. So this will be, this is an equation where m2 is in LHS and m1 only m1 is in RHS. Okay, gamma and m1 in RHS. So m2 as a function of m1, you have got such an equation. So if you simplify it once more, so you divide by 2 into gamma minus 1, divide numerator, divide numerator and denominator by 2 gamma minus 1. So you will get m2 square is equal to 2 by gamma minus 1, 2 by gamma minus 1 plus m1 square by 2 gamma by gamma minus 1 into m1 square minus 1. Okay, so this is the equation, for Mach number in the downstream, the Mach number of the downstream of normal shock with in terms of Mach number of the upstream of normal shock. Okay, Mach number upstream of the shock. So students, don't worry about this equation. This equation is available in your gas table. So you don't need to memorize this by heart, this particular equation. All equations are available in your gas table. So you don't worry about the equations. So whenever you are asked to derive an equation, you are asked some derivation, you just need to know the starting. Okay, where to start and the what all things should be substituted, and you don't need to worry about the simple algebraic rearrangement. Even if you skip those rearrangements, don't worry about it, your marks won't be cut. Okay, so you do the first initial steps, where to start, what all things should be substituted, what all rearrangement should be done. Okay, and even if you are not getting the final answer, you don't worry, this answer will be available in your gas tables. Okay, so please have a look at this equation. So this equation reveals that for a compressible fluid, for a perfect gas undergoing a normal shock, so the Mach number downstream of a normal shock is a function only of the Mach number upstream of the shock and gamma specific heat ratio. The function m2 is a function of m1 and gamma only. Okay, m1 and gamma only. So when m1 is unity, that is whenever m1 is equal to 1, m11 means here it will 2 gamma. So what will be the value of when m1 is equal to 1? What will be m2? m2 will be like 2 by gamma minus 1, 2 by gamma minus 1 plus 1 by 2 gamma by gamma minus 1 minus 1, 2 gamma by gamma minus 1 minus 1, right? So when m1 is unity, so if you rearrange this, you will get 2 plus gamma minus 1 by gamma minus 1 by 2 gamma minus, okay, minus gamma minus, sorry, plus 1 by gamma minus 1, right? So gamma minus this denominator gets cancelled, and 2 gamma minus 1 is gamma plus 1. Okay, this is gamma plus 1 and this is gamma plus 1, right? 2, so this will be gamma 2 minus 1 is 1, gamma plus 1. This is 2 gamma minus gamma plus 1. So this will yield you m2 is also is equal to 1, right? So when m1 is 1 means m2 is also 1. So what is the meaning, physical meaning? When the flow is sonic, after the m2 will also be sonic, means there won't be any normal shock. It is a case of weak normal shock. Weak normal shock means there is no steep pressure rise, because both upstream and downstream are having both sonic velocity. There is no change. But when m1 increases, or the weak normal shock is Mach wave. Okay, Mach wave. But when m1 increases more than 1, means normal shock becomes stronger, because normal shock only happens when m1 is more than 1. That is for supersonic flow only. Okay, so m2, when m1 increases, means m2 will progressively decrease less than unity, will be less than unity. Okay, so you can deduce from the equation that when m1 approaches infinity, m2 approaches a value of gamma minus 1 by 2, root of gamma minus 1 by 2. So you can have a look at this equation. So whenever m1 approaches infinity, means infinity, so you can see from this equation, when m1 increases, or m1 increases means upstream velocity is supersonic, means m2 will decrease, definitely decrease. Okay, so now we will determine the velocity and density ratio across normal shock. Velocity and density ratio. Across normal shock. So you know that v1 into v2 equal to a star square, right? So v1 by v2 is equal to v1 square by v2 v1, right? So I am multiplying v1 in numerator and denominator. So is equal to v1 square by v2 v1 is a star square, right? A star square. And v1 by a star is nothing but m star, m1 star, that is reference Mach number, m1 star square. Okay, so using the relationship for m1 m star, so you know the relationship between m star and m. you learned in your first module. So v1 by v2 is nothing but v1 by v2 is m1 star square, right? So that's what we have obtained. v1 by v2 is m1 star square. So v1 by v2 is m1 star square means m1 star square can be written in terms of Mach number. You uh, just go back to your first module and see the relationship. It is like this: gamma minus 1 into m1 square plus 2. So this is the relationship between, if you know the reference Mach number, you can write that reference Mach number in terms of original Mach number. Gamma plus 1 into m1 square by gamma minus 1 m1 square plus 2. Okay. So students, since rho v is constant, we have already learned the equation, the continuity equation. Rho v is constant. So v1 by v2 will be equal to rho 2 by rho 1, right? Rho 2 by rho 1. Okay. So v1 by v2 is nothing but gamma plus 1 m1 square by gamma minus 1 m1 square plus 2. So this will be also equal to rho 2 by rho 1. So v1 by v2 equal to rho 2 by rho 1 equal to gamma plus 1 m1 square by gamma minus 1 m1 square plus 2. Okay, so that's the relationship between velocity and density across the normal shock. Now pressure ratio across, pressure ratio, very important, pressure ratio across normal shock. So in case of pressure, since normal shock is a compression process, right? So the pressure ratio across the shock will be the indication of strength. It will indicate the strength of the shock. Actually, we have learned that normal shock is nothing but a steep rise in pressure. So pressure ratio across a normal shock will yield you the strength. It will give you the idea of strength of that particular shock. When the initial Mach number is unity, the pressure ratio will be also unity because there won't be any normal shock. It will be a weak wave or Mach wave. As the Mach number increases, incident Mach number increases, the strength of the compression wave increases. Okay. And we know the momentum equation P1 plus rho 1 V1 square is equal to P2 plus rho 2 V2 square is equal to a constant. Okay. So rho V square can be written as, rho can be written as P by RT into V square, right? So if I am multiplying a gamma here and here, numerator and denominator, it will become gamma P V square by gamma RT is nothing but A square, right? So V square by A square will be gamma P max square, gamma P max square. Okay. So I am substituting this equation here. Instead of rho 2 V2 rho V square, P1 plus gamma P1 M1 square is equal to P2 plus gamma P2 M2 square, right? So P1 common 1 plus gamma M1 square equal to P2 common 1 plus gamma M2 square. So P2 by P1 is equal to gamma plus, 1 plus gamma M1 square by 1 plus gamma M2 square. So this is the ratio of pressure across the normal shock. But for practical calculation, the equation for pressure ratio in terms of incident Mach number M1 is required. So students, actually in the questions and all, we will be given only the Mach number of incident wave or the upstream wave. So if you, in most cases, you won't be knowing the value of M2. Otherwise, if you are given M1, you should be able to find M2 using the equation we have already mentioned, like this equation should be used. Okay, this equation should be used. This is the equation. Okay, But instead of that, using that equation coming, I think we can simplify this equation. You should be able to write P2 by P1 as a function of gamma and Mach number 1 only. Then there won't be any need for finding M2 using M1 separately. You can directly use this equation. So how to do that? So students better use this. So 1 plus gamma M2 square is there, right? So here 1 plus gamma m2 square is there. That should be avoided. So 1 plus gamma m2 square can be written as 1 plus gamma m2 m2 in terms of m1 we have already written 2 by gamma minus 1 plus m1 square by 2 gamma by gamma minus 1 m1 square minus 1. Okay, this is the equation for m2 square. Now you just rearrange those equation and you will get if you simplify it, you will get 1 plus gamma m2 square as, after simplification, you will get it as gamma plus 1 by gamma minus 1 plus 1 plus gamma m1 square by 2 gamma by gamma minus 1 m1 square minus 1. Okay. So substituting this equation for P2 by P1, so P2 by P1 will become 2 gamma by gamma minus 1 m1 square minus 1 1 plus gamma m1 square by gamma plus 1 by gamma minus 1 into 1 plus gamma m1 square. Okay. And now this 1 plus gamma, this these two terms get cancelled, right? And finally rearranging this, you will get you just divide this term by this term. Okay, so I think this gamma minus 1 cancels here, and what remains is P2 by P1 is equal to 2 by gamma plus 1 m1 square minus gamma minus 1 by gamma plus 1. Okay, so this is the equation for pressure ratio across a normal shock. So again, students, you will be wondering what happened, what was the steps in between these two steps, right? So I wrote 1 plus gamma m2 square equal to 1 plus gamma m2 in terms of m1, and all of a sudden I have written this equation. So what I have done is I have skipped the algebra. Okay, so uh, I was leaving those simplification for you to do as an exercise. And even if you are not able to do this, do those steps, don't worry, you have the final equation with you in your gas tables. So that is why I'm not taking a lot of stress in solving those algebra. Okay, so even if you don't know, so you if you even if you don't get the idea, or you are not able to do those simplification, don't worry. You are not judged based on your simplification power in algebra. You just need to know the concept of all those concepts related to this normal shock. So you will be assigned with you will be evaluated based on your knowledge in your subject, not merely based on your simplification power in algebra and all. Okay, so that's why I'm skipping this. So you just try it on your own. If you are not getting, I will help you. Okay, now this is the pressure ratio, and now we will move to temperature ratio across normal show across normal show. So T2 by T1 should be found out. So T2 by T1 can be written as T2 by T02 into T01 into T1, right? Because T01 is equal to T02. So this and this, these two terms get cancelled and remaining T2 by T1. So T2 by T1 can be written as T2 by T02 into T01 by T1. So T2 by T02 is nothing but stagnation, the static to stagnation. So that equation you know. Okay. So T01 by T1 is T01 by T1 equation you know, T02 by T2 equation also you know. So I am just substituting it and you will get T2 by T1 is equal to 1 plus gamma minus 1 by 2 m1 square, and in denominator you will get 1 plus gamma minus 1 by 2 m2 square. So students, what should be done? You should be able to get T2 by T1 in terms of as a function of gamma and Mach number 1 only. So you have to remove m2. So not to remove m2, you just put the equation for m2 in terms of m1. So that equation you already studied. Which equation? This equation. You substitute this equation. Okay. You substitute this equation, you will be able to uh, so here, instead of 1 plus gamma minus 1 by 2 m2 square, I am substituting 1 plus gamma minus 1 by 2 m2 square can be written as 1 plus gamma minus 1 by 2. Instead of m2 square, I will substitute 2 by gamma minus 1 plus m1 square by 2 gamma by gamma minus 1 m1 square minus 1. Okay. So as usual, you have to do simplification, and finally you will get like this equation: 2 gamma minus 1 m1 square by 2 gamma m1 square by gamma minus 1 minus 1. Okay, so this is the final equation, and after substitution you will get, after substituting 1 plus gamma minus 1 plus gamma minus 1 by 2 m2 square as this one in terms of m1 only. So if substitute it here, you will get d2 by t1 as 1 plus gamma minus 1 by 2 m1 square into 2 gamma by gamma minus 1 m1 square minus 1 gamma plus 1 2 gamma minus 1 square m1 square. So this is equation for temperature ratio across the normal shock. So students, again I am saying that you won't be able to memorize this equation. So since I have skipped those intermediate steps, you won't be able to reach this equation directly. But since this equation is given in your data book, there is no need for memorizing this equation. So it's very difficult to memorize so much. There are a lot of equations in this subject. It won't be easy for you to memorize all those things. Okay. So that is why we are using uh, gas tables, and while doing problem and all, there is no need for using this equation itself, because we are doing problems based on tables only. All values for corresponding to a given Mach number and given a gamma, the ratio of T2 by T1 is tabulated. So you don't need to apply this equation itself. Okay. So hope you are understanding what I am trying to conveying to you. So if you have any doubts, you just contact me. Okay. Don't hesitate. So this is the equation for temperature ratio. So similar to pressure ratio, it is a function of Mach number alone, gamma and Mach number alone. Okay. Now I think two more relations are there: stagnation pressure ratio. Stagnation pressure ratio means P02 by P01. P02 by P01 can be written as P02 by P2 into P2 by P1 into P1 by P01. So how to solve? Can you solve can you solve this equation on your own? So already we have found the relation for P2 by P1. You know the you may be knowing the this P0 by P equation for P0 by P is already known to you even from the first module itself. Okay. Similarly, P1 by P01 is also the inverse of this ratio. So applying all this ratio, you will get a final equation. Okay. So I am not writing those final equation. I am leaving this to you. You just study on your own. You don't worry about the final equation because final equation is already given in your data book. Okay. You just try to do it. Okay. That's all. These equations won't be used in any of the problems because problems are done based on tables. Table for normal shock is there. Okay. Similarly, stagnation to one more ratio is there. Stagnation to static pressure. Static pressure ratio. That is P02 to P1. The stagnation pressure of downstream value and static pressure of upstream value. So this should also be known. That can be found out using the P02 by P1 can be trans P02 by P2 into P2 by P1. This P2 by P1 is already known. P02 by P2 that relation can be obtained. That relation is already known. Stagnation pressure ratio. Okay. So applying those relation, you can find that final equation also. I'm leaving it to you. Okay. And I think you do this two relationship as an assignment. I'm giving you as an assignment. So assignment, okay. Assignment. So this is also an assignment. Okay, with this I think I will stop this session. Thank you.